Okay, so today's section 1.2, finding limits graphically and numerically. I'm just going to do a brief introduction of what a limit is and limit notation, and just briefly talk you through this first example. You can choose what you want to write down. So we're going to sketch f of x equals x cubed minus 1 over x minus 1. In pre-calculus, we had like 8 steps that we would do, where we would find x-intercepts and y-intercepts and vertical asymptotes and horizontal asymptotes. And here we could do those type of curve sketching things. We could also make XY tables and just plot points and see what's going on. But the most important thing is we're wondering what really happens here at x minus 1. I'm sorry, at x equals positive 1. Do we get an asymptote? Does it divide out? If you remember about factoring differences of cubes, you realize that it does actually divide out, which means that there's a hole in the graph at x equals 1. So we're going to make this little table. So I'm skipping all the steps of making this table, but we've got an XY chart. It's just going horizontally instead of vertically. And right here in the center of this chart, we have x equals 1, because that's what we're trying to figure out. What happens at x equals 1? So what we do is we start here and we start approaching 1 from the left, which is like from 0 all the way up to positive 1. So from like 0 to 0.99999. So that's what they've done. They've just jumped in at 0.75. 0.9, wow, 0.9 is pretty close to 1. 0.99, that's really close to 1. And 0.999, well, we might as well almost say we're at 1, so because it is so super close. And then they've taken those values and they've plugged it into this function. The easiest way to probably do that would be to put that into y equals and use table set to choose these specific x values. And then you can just change the x values each time and write down what that gives you in your table. So sort of toggling back and forth between table set and table to see what those values are. And then on the right side of positive 1, we're going to start out here far away from positive 1. And as we move this way, then we're going to get closer and closer to positive 1. So we might think about starting at 2, and they started a lot closer at 1.25, 1.1, 1.1, that's really close to 1, 1.01, and then 1.001. The idea being the closer we can get to 1, then we can talk about the limit idea. So still doing table set and still seeing what we get on our table. Now look at these actual values that you get as your x value got closer and closer to positive 1, your y value is like 2.3, 2.7, 2.97, 2.997. That's super close to 3. And on this side, we start out at 3.8, 3.3, 3.03, 3.003, and you can just imagine if this x value, if my next x value was 0.9999, then my next y value would probably be 2.9997. I had to count my nines there. And if this x value here had been 1.0001, this y value would probably be 3.0003. So we're getting super close to 3 from both sides as we approach 1 from the left and as we approached 1 from the right. We're getting super close to 3. That's the idea of a limit. So we are approaching the same number from both sides of the number that we were in question about. Then we could say that the limit as x approaches 3, x approaches 1 is 3. the limit as x approaches 3 is, I'm sorry, I keep saying 3. As x approaches 1 is 3. And try to use the right notation and try to hear yourself read it correctly. Don't say the lim. Say the limit as x approaches 1 is 3.